You can now streamline AI agent evaluation by using synthetic evaluation sets. So Maria, can you tell us what the purpose is of synthetically generate an evaluation set for AI agents?
Yes, so this synthetic generated data allows us to create a representative set of test cases to measure the quality of our agents. Why this is important is because we can avoid the very time-consuming task of manually evaluating our agents and to make sure that we have a good coverage for our agents' functionality.
Great. And so what are the parameters that you can use to control the generation of those evaluation sets?
Yes, so you can see it here on the documentation. We have three main additional parameters that we can control. One is the num evals, which is really the total number of evaluations that we will generate with this synthetic generated process. Then we have the agent description, which what it does is just you describe what is the task of the agent. And then you have question guidelines where you explain what questions the agent should expect, and you can add a couple of examples as well in there of potential questions.
Awesome. And can you tell us more about the method that's used to synthesize the evaluation data sets?
Yeah, so the main key thing here that does the trick is the generate evals data frame that you have. This is the output of the function that we are going to call as we're going to show into the code. And what it returns is these four different rows. One is the request ID, like unique identifier on the data frame, the request, so what was the synthesized question generated, the expected facts, these are the things generated again from this process, but it writes specific facts that answer the question instead of a fully comprehensive answer, to be honest. And then it adds this expected retrieve context. This is the context that the answer, the generated facts, were created from. So we will show exactly in the code how this works.
Awesome. And how does the num evals parameter distribute evaluations across the documents?
Yes, so as you can imagine, because there are not a lot of things you can configure here, the num evals is a very key parameter. And that because this covers how much coverage we're going to have on our dataset, right? So imagine that you have 15 documents and you say, I want a num eval equal 1, right? So only one generated example. This means that only one example will cover one of the lines in your document or one of the specific parts or chunks in your document. So at least you have to have 15 to cover all, right? So this is what we are saying with that. So how do you choose wisely this num eval to have a full coverage? And what you can do is after you, let's say, put a num eval in place, you can see what you get. And in the return, in the expected retrieve documents, you also get this doc URI. This doc URI matches which specific document this question and answer was synthesized from. So now you can see which documents are covered in the answer, in the synthesized dataset or not. So that you can go back, limit your dataset to the ones that were not covered and do the same synthesization again.
Awesome. So basically what you're saying is that the num eval is a tricky parameter and it really needs to be configured correctly. Is there anything else that can be used to estimate the number of evaluations that are needed for, your desired coverage?
Yeah, so apart from the synthesization function that we provide, we also have we also have one more function, how to estimate the synthetic num evals. And it's just a function that you say, this is my documents, this is all the documents I need to synthesize data for. And by passing, now again, you have to define and after how many tokens you need a new evaluation example. Based on the number of tokens, it creates evaluation sets, basically. So if you have 1,000 tokens here, it's going to create one evaluation example for each 1,000 tokens on your dataset. But in that way, you can make sure you have a good number of num evals to at least achieve a proper coverage.
Awesome. Let's see the demo.
Yeah, for sure. So if we share this tab now, Okay, so what we're going to do is we are going to use the functions we just described and try to understand how to use them in a real example. Again, here the dataset look like Databricks documentation. So we have scraped our Databricks documentation and we're trying to create an evaluation dataset for our agent. So we're going to have an agent that receives a question based on some Databricks questions or some asking questions on the Databricks product. The agent needs to go and fetch the required documents to return. It's based, this is not a RAG system in this case, it's just a keyword search functionality with just a tool that we're going to build, like a UC tool. And then what we're going to do is we're going to launch the agent and try to evaluate it and compare using this synthetic data set for evaluation. So the first thing is to understand a little bit the data set, and this is what it looks like. So this is the content, what is Databricks, blah, blah, covering different parts of the product and where to find this information on the Databricks page. And this is the data set that we will use to create synthetic questions and answers on. Now, in order to create this synthetic data, you need to use, as we said, this generate eval df function. So we will go and fill all the parameters that we said when we were going through the documentation, and that is the agent description. So what is this agent about? So the agent is a chatbot that answers questions about Databricks. The question guidelines, we said, what kind of personas, what kind of examples, what extra guidelines we need in these questions and answers. This is used to, match a specific pattern that we need or we expect to see in our incoming data. And then now we have the num evals. So how many evaluations we are expecting or we want from this function. So 25. And then we just hit the function, we pass the docs, we pass the num evals, the agent description, and the question. And output of this.
Here we're talking about 25 question answers.
Bravo. 25 evaluation examples.
Yeah.
And the evaluation examples looks like this. So we get the request ID, so the unique identifier of the request. This is the question the question generated, right? What is the purpose of the transform complex times, This is what it generated as a question to be asked to the bot. This is the expected retrieved context. So this is not the generated context, but this is what content it used to generate the answer. So the answer is in the expected facts. Remember that the answer of the synthesized process, it doesn't appear as a proper configured answer, but as facts. And that is because it helps when humans go and review and see if this is a good or a bad evaluation example. Facts helps you actually better match or go through the information you need to make sure that it's a good or a bad example. So that is why it comes through facts and not as a full answer. And the last thing that you have here is the source as well, so that again you know which part of my documents this question refers to or was created from, and also for the coverage that we said before too. So this is how it looks like. And as you can see, we have 25 rows, which matches the num evals. So then that is really the evaluation part, right? It's really easy to configure. Then we go through building an agent and start understanding how we can use this data set to compare different agents. So we will share the link to this code, but what we are mainly doing, we are going through the same creation process of building any agent on Databricks, right? So we're going to have some default configurations. We define some parameters like which model we're going to use, temperature, max tokens, what is the system prompt, etc. And then we said it's not going to be a proper RAG project, in this case where we have a vector search. What we're going to do is we're going to just build a retrieval tool which we'll have a function behind the scenes that fetches the question, checks which keywords exist in each part of my chunks, and return the chunks that the keywords match. It's keyword matching mainly. And this is my agent. So we have the class of the agent. We will initialize the agent, and then this is a function that mainly helps us to return back the chunks from the relevant chunks so that we are able to compare and check. And this is where we are passing all the tools, as we said, because this is going to be keyword matching. We're going to define this search product doc and pass it as a tool into our agent so that the agent is able to see and use it. And here we define the predict function, where it takes the messages, it manipulates them and put them into the right format, and then it just hits its completion response. So this is the tool that we described before, which does the keyword matching. And as you can see, it takes the query. If there's no query, if it's empty, then it returns an empty list. But if there is, then it goes to the chunks and starts matching the keyword to the chunks. And this is what it returns through the process. And there are a couple of helper functions to help you with recursively calling the right tools and etc. Go through the code, we'll share the link. But what I wanted to show you here mainly is when you call the agent. So when you call the agent, what happens is you pass the question, and then let's see what is happening in the trace. So you take the question, it goes and hits the tools, right? So builds the right format, then execute the tool that we said above, which is the tool for matching the keywords. Search for all the product documents. These are the documents that the keywords that were in the query is matching in the documents, and then goes and passes through the LLM that we have to just formulate a nice answer. And that is what it does. And now what we have done is just making sure that the agent is working.
Yeah.
The next thing is as now we haven't used the evaluation dataset at all. So now is the point where we can use this evaluation dataset and see how well this agent performs on this evaluation data. So in order to do that, we are going to build this evaluation function, which what it does is it takes an agent and then a specific run, and then performs the evaluation with MLflow evaluate. So in the data we pass the evaluation dataset, the synthetic evaluation dataset we created before, the agent URI, and then making sure that we say it's a Databricks agent. So now what we're going to do is...
So here, just a quick question. Yeah. We need to make sure before that the evaluation data set that was generated is reviewed and validated by SMEs, right?
Very good question. Very, very good. True. So after you have created this evaluation data set, there is the process that you're going through each example and you accept it or not accept it. And we have a UI for this too, that we can link a separate video as well.
Sounds good.
And then what we do is, given this synthetic evaluation example data set we are going to test it against different models. So in this case, we're going to pass as an LLM to our agent the Llama 70B, and we're just going to get the evaluation results for the specific agent. So we're just changing the agent configs in this case, and we're saying we're using the Llama 3.1 70B instruct with these specific parameters, and this is the system prompt, and this is the name of the run, the 70B instruct. So as a result of this run, you can see the evaluation results for this specific agent. So as you can see, it went through all the 25 questions and passed them through the LLM judges for correctness, context sufficiency, and etc. and safety. And this is the default metrics we are capturing. And this is for the first agent, the one with the Llama 3.1 70B, remember. Now, what we can do is we can run exactly the same thing with different parameters and start having different versions of the same agent. And the idea here is to use the different versions of the agents, compare them again, evaluate them on the same synthetic generated dataset, and then compare the agents between them. Now, again, what you have to do is just change the config. So we're going to change the config, pass a different model, and then hit the same function again to create a different run with a different LLM behind the scenes.
Amazing.
So if you go here, you can see the evaluation results for the other agent. So now you can see that, right? And here you can see if you can go through each and every one of those, right? So you can go inside, see why it fails, what are the things you can change to make it pass. But let's say here that the overall percentage is 20% here, where in the previous one was actually 16. Given this synthetic evaluation dataset, remember, the first agent is better. Now, what you can do also is you can go and compare these results between them. So you can come here. These are all the runs that we logged in this specific experiment. So if you go to the 405B and 70B, you can do compare, and then you can see them side by side. And you can see, for example, how long it took for each one to run. So this one was it took more time than this. So if latency is an important thing, this is something that you can start monitoring. And then you start seeing all the different metrics and compare not only how many of them passed the evaluation dataset, but in terms of precision, accuracy, and anything else that you want to add for comparison. And this is where the synthetic part finishes really on the synthetic generation of data. The next thing that you can always do, remember, is that you can log this, serve it, and also deploy a review app on top if you want to start asking for your SME to review your question and answers and give feedback as well, as we always do.